going to start with quadratics. We're going to look at quadratics and cubics today. Now, quadratics are easy. Because quadratics, we know how to find the maximum and minimum values. There's only one. For cubics, we don't know really how to find the maximum and minimum values because there aren't technically maxes in there. So let's talk about a quadratic function first. This function is in standard form. F of x equals ax squared plus bx plus c. The max occurs at the axis of symmetry, and what's that maximum called? The vertex. And if you're in standard form, if you really want to find the vertex, how do we do it? Yeah, you got that. Now that's the x-coordinate or the control variable value of the vertex. How do you find the dependent or y-coordinate in this case, or f of x? Yeah, you plug this in. So plug in x to get the y. Okay? Now again, that's in standard form. And you're certainly welcome to find the functions in standard form. However, you'll see that we have another option. And if you needed it, which you don't, the axis of symmetry is through the vertex, so it's x equals the opposite b over 2a. But that axis of symmetry, we can find that value opposite of b over 2a other ways, depending upon which form you're in. So if you remember a of x, or whatever, a times x minus p times x minus q, what form is that? That's intercept form. Very good. How do you find the x-coordinate of your vertex if you're in intercept form? Anyone remember? P and Q? Who's them? Start with that wimping out. Who is them? You said add them together and divide by 2. Who is them? Add P and Q. So P plus Q divided by 2. Don't wimp out. You know what it is. Tell me. Use better words than them. Them would be unclear as to what we mean. How do we find out the y-coordinate of the vertex? Plug in the x. We're mostly going to look at stuff in intercept form today unless you just want to move it into standard form. So if you want to move it to standard form, that's fantastic. But that's just extra work. Now I'm going to take you through the problems. You're going to see variations on a theme here. All right? So the first one is your standard, let's make a enclosure. And it's 2 dimensional. A rectangular dog pen in this case is constructed using a barn wall. That's one side. Here's the barn wall. And then 60 meters of fence to enclose the rectangle. We don't need to put fence along the barn because the dog can't get out through the wall. Find the dimensions of the pen that give the greatest area. All right? We have a roll of fence, and we're going to unroll it to make this pen for our dog. I'm not sure what Dave's cabin is doing here, but maybe that's the back or the front of the barn. First thing you start with is a let statement. Now this let statement, honestly, we should have 3 things in the let statement. And the first one is to, whatever you want. You'll let you decide where we go with this let statement. Anyone want to take a shot? What are we going to do first? What are you going to let? Your let statement is where you define your variables. If you're not sure what a let statement is.
Well, I was going to say you have 60 meters of fencing. Is that part of it?
Well, it's not part of a let statement because that I already know what that is.
So you're trying to tell us how long the sides are?
All the sides?
3 of them?
So they're all the same?
The rectangle, the,
So all 3 sides of the rectangle are the same, so the answer to the question is 20 meters.
because they're looking for what has the greatest area.
Right, but you said all 3 sides have to be the same, and we only have 60 meters. That means each of the sides has to be 20, right?
They don't have to be the same.
Then we can't make the variable be the same. Okay? Let x equal the width of 10. So as soon as I make that kind of a let statement, I'm going to put that in my picture. The picture for me is indispensable because I'm a visual kind of guy. I want to see it, and that helps me get through the problems, especially with the sketch. I'm going to sketch the graph too in a little bit once I have a function. So if x is the width, how much fence do we have altogether? 60 meters. So how much fence do we have left for the length of this dog pen? 60 minus 2x equals the length of the pen. No, we don't want a different variable. You do not want 2 different variables for your dimensions because your second variable is really going to be the thing you're looking for, in this case is area. Okay. So this is 60 minus 2x. If we didn't have a barn and we were going to be doing all 4 sides and x is the width, how long are the lengths going to be if you needed to do fence on both sides here? We don't, but if we did. $60 minus 2x. This is how much fence you have. The 2x is how much we used. And since we need to do 2 sides now evenly, we would take that and divide by 2 and get 30 minus x, or 60 minus 2x over 2. Everybody follow that logic? Because you're going to need that logic later, actually in your homework. If you're doing this side and this side, how much do you have? How much did you use? 2x. Subtract those. And then if you're doing both, then you divide by 2. But in this case, we're not. We're doing what is the function? We're doing area. So area in terms of x is going to be the area of the pen. What is our area function going to be? And this is why I like the picture. X times 60 minus 2x. How do you get that? Length times width, because it's a rectangle. That's how you find the area. Thanks. Everybody following that? So if I do a little sketch, Corey, can you tell me what the x-intercepts are? Don't overthink this. You have a function. What are the x-intercepts?
0 and 30.
0 and 30. What are the values of x that make each factor equal to 0? 0 and 30. So here's 0, here's 30. What's the leading coefficient if you wrote it in standard form? Is it positive or negative? Negative. So is this horseshoe up or down? Down. So our graph's going to look like this. That's the way the area would work. if x is 1, we're going to be looking at 1 wide and 58 long. You're going to have this long, skinny pen for your dog. Your dog's going to be able to go like this and like this. Not even going to be able to turn around, not enough room if you have a big dog. Okay? And then as you increase x, we increase our area until we get to our maximum. Where is the maximum going to occur? When x is, it's the vertex, and when x is 15. How do you get that? Halfway between 0 and 30. Halfway between the 0 and the 30. Okay? Kevin, where or what will the maximum area be for this one?
150.
How much?
150.
How'd you get it? And so, how would you answer the question?
Max area would be 450.
Keep going. Let me help. I can't remember either.
60 or 450 meters squared.
450 meters squared. Okay. What are the dimensions of the pen? Meters by 30 meters. Now, what did they ask? What did they actually ask us to find? Which one of those? Find the dimensions that give the greatest area. So the dimensions would be 15 meters by 30 meters. Now, I am a hard ass on graphing or on grading these ones. Okay, I'm not negotiating with you. I let some things go in chapter 1 that won't fly in chapter 2. So in this, for me, first thing I'm looking for is your let statement. That's a point. I want to see a picture. It doesn't have to have a dog or, just a sketch with the labels on the picture. I need to see your function itself. A of x equals. And then I need to see, you don't have to do this sketch. I will have the sketch, but that's not mandatory. Your intercepts you're going to have to identify either in the sketch or over here you can put 0, 0 and 30, 0. And your vertex is going to be 15, comma. And then when you plug the 15 in here and here, you answer the question like this. Do not give me an answer of x equals 15. That's not going to fly. Do not write 15 by 30. You need to say the dimensions of the pen are 15 meters by 30 meters. If you do not have meters, you'll get marked down. And I'm telling you all this just in full disclosure. When I graph these, they're worth a lot of points. You get points for each of these bits. So make certain that you meet these minimums. Everybody follow this so far? Okay. Pretty basic quadratic. This is a pretty common question. We're going to put a pen together. That pen could have a barn on one side or a canyon on one side, and then the rectangle like this, or it could be a fully enclosed pen. Okay, it could be a pen they could even give you this kind of a pen. This is in the homework where you're going to do this. So you're going to have a big pen with a divider down the middle, so you need fence here, here, and here. Okay, so if this is x, you let the width be x, and you can see we're going to have 102 meters altogether. How much have we used up so far? 3x, right? And we had 102 total. How much fencing is left after you build these three sides? 102, take away 3x. What are you going to do with 102 minus 3x? Because we got to put fence here and here. Divide by 2. That's where the 102 minus 3x over 2 would be. Okay? See if you can write the let statement for this one. Yeah. No, I mean on your paper. Okay, like I said, there's more than one correct let statement. And I saw at least 2. Everybody should have the first one the same. Let x equal one of the numbers. Now, what could you put for the second statement? The other number. And what would we let the other number be? Okay, you could do 6 minus x. What else could you put? X plus 6. What else? X minus 6. All of those will work for the second number. X is one of your numbers. X plus 6, X minus 6, or 6 minus x. Okay? So if we do 6 minus x, we want to say two numbers have a difference of 6. Okay? Find their minimum possible product. So x, 6 minus x, those differ by 6. Let's see. I don't think those differ by 6. I don't think x and 6 minus x differ by 6. Because if x is 1, they don't differ by 6, right? So this one's not going to work as your let statement. So x minus 6 will work. And what are we trying to find? What are we trying to find here? Minimum what? Product. What does that mean? So let's do P of x is equal to x times x minus 6. What kind of a function is that? Quadratic. Leading coefficient? Positive. X-intercepts? 6, 0, in this case, and 0, 0. If you used, what was the, x plus 6, then you had negative 6 as your intercept, and that works fine too. Okay. If you used x plus 6 here, that would work also. The graph is going to look like this. It's a sketch. And we're trying to find the minimum possible value for the product. How am I going to find out where that is? And how will I get it? Why 3? Halfway between the 0 and the 6 is going to be 3. Or if you had your negative 6, it would be a negative 3 you're going to plug in. Doesn't matter. So the x coordinate of your vertex is going to be 3. What's the y coordinate of your vertex going to be? Negative 9. What does it ask you to find? The numbers? Product. So what's the answer going to be? The minimum product is negative 9. What if they wanted to know what the two numbers were? Nope. Yeah, aren't we talking about two numbers? What if they want to know what are the two numbers? What would they be? What are they?
3 and negative 9.
Nope.
3
Nope.
and negative 3.
3 and negative 3. How'd you get those?
Because you put in 3 for x, so 3 minus 6
When x is 3, one of the numbers is 3. 3 minus 6 is the second number. Negative 3. That's why we do a let statement. So we know what the things are that we're trying to figure out. The two numbers are 3 and negative 3. If you used x plus 6 and you got the negative 6 and 0, 0, the x value you found was the negative 3. Negative 3 plus 6 gave you the positive 3. You still get the same answers. The numbers are 3 and negative 3. But this question wasn't asking me for the numbers. Anybody have a question on this one? What if I told you you need to find two numbers that are consecutive odd numbers? What would your let statement be? What are consecutive odd numbers? X would be your first number, and x plus 2 would be your second. Let x equal first odd, and x plus 2 equals the second odd. We're talking about consecutive odds. How do you get from one odd to the next? You add 2. What if I wanted you to find consecutive evens? Same thing. X would be the first even, x plus 2 would be the second even. And if they were consecutive integers, x and x plus 1 would be consecutive integers. Okay, this is a pretty common problem where they ask you to take something that's two-dimensional and turn it into something three-dimensional by folding it. Sometimes you have a piece of paper, you'll see in your homework tonight, you'll take a piece of paper, fold it 3 times lengthwise, and turn it into a prism. Okay? In this problem, it's a box problem, and the box is going to be open when we're done. We're going to take this happens to be a piece of sheet metal, it could be a piece of cardboard, whatever. Okay? And what we're going to do, excuse me, is we're going to take, and the sheet metal is a big rectangle. And from each corner of the rectangle, we're going to cut out a square, same square in each corner. And we just throw that piece away. Then we're going to take these flaps and fold them up. So we can each flap fold it up, fold it up, and fold it up. And you're going to get an open box. And we're going to try to figure out what the maximum volume of that open box will be. Now the problem is, when we're writing the function, you're going to see it's going to be cubic. So the cubic function is going to be more difficult to figure out what the max and min values are. Okay? So, we're telling you we're cutting out sides length x. That's usually your unknown. So on all of these corners, we're cutting out a little square, x by x, and throwing those away. Remember, the original dimensions were 10 inches by 6 inches. 10 inches by 6 inches. When we fold it, you're going to get this box like this. How tall will the box be? When we fold up these sides, the box will be x units tall. Now, how far, or what will the dimensions, the length of the bottom of the box be? 10 minus 2x, because you took x away here and here, so this piece will be 10 minus 2x. So this, 10 minus 2x. And what will the width of the bottom of the box be? 6 minus 2x, right here. Here. So that's 6 minus 2x. Now you didn't have to make a let statement for this because they gave you x as the length or the dimensions of the square that you cut out. Now we're trying to find the volume based on x. What will the volume based on x be? X times 6 minus 2x times 10 minus 2x. How do you know that? Length times width times height is the volume of a prism. If you were to multiply that all out, what type of a function would we have? Cubic. So, degree 3. Leading coefficient? Positive. End behavior? I'm changing it? I don't know. Hang on, we're going back to leading coefficient. Thomas? When we multiply this times this, what would you get? So you're not going to play with me? Okay, I'll just go be by myself. On the left then, what are we going to be? Down on the left, up on the right. That's your end behavior. What are your intercepts? 0, 0. 5, 0. 3, 0. So if you do a quick sketch, just to see what's what, if we were to do a quick sketch, we would have intercepts at 0, 0, 3, 0, and 5, 0. And you said it would be down on the left, up on the right. It would look something like this. Okay? Now, it's not a trick question at all. The domain of this function, does anyone know the domain of this green graph? So how do we describe that? All reals, somebody said. It's unlimited, it's infinite, all reals. So x can be anything. What about the range? Also all reals. Is there a maximum on this function? No, this thing's going through the roof here. Okay? Now we have to come back to reality. Okay? Is there a maximum and minimum value for the value of x in this function? What is the maximum, or let's do minimum first. What's the smallest value x can be? 0. It's got, and technically it has to be greater than 0, right? So your domain, if we were going to list the domain, your x has to be greater than 0. Okay? What about the maximum value for x? Be careful on this one. Yeah, let's just say it was 4. Could it be 4? Try a 4. What's the width of the base if it's x is 4? Yeah. How many negative width bases have you ever seen? None. What's the maximum value for the domain? It's got to be 3. So when you look here, we need to be less than 3. Now, in interval notation, it would look like that for your domain. We do reverse bracket 0, reverse bracket on the 3. The reverse brackets are telling you that we go up to, but we don't include the 0. So we shun the 0, shun the 3, up to, but not including 0 and 3. And if you look at your graph, you can see when x is 0 to where x is 3, we have this part of our graph. What are the y values in the graph telling us? No. What are the y's on this graph telling you? The volume, not necessarily the maximum, but the volumes. The y values of every point on the graph are volumes. The x values are how big the squares were that we cut out. This dimension, the height. Okay? Now, we want to find the maximum volume. That's going to occur right here. And honestly, none of you can tell me what that value is. I can't tell you. You can't figure out what the x is, nor can you find the y. Now, in my crappy sketch, you might be tempted to think, oh yeah, but it's halfway. Not so much. It's this value right here is not a quadratic, it's cubic. And this value is not going to be halfway between these intercepts. It's actually going to be closer to the x-axis, I believe. So what I'm going to ask you to do is to use your graphing calculator on these problems. If you don't have one, you can use one of mine. Okay? If you need to come to class early, before school or after school to figure those out, you do everything that we've done up until this point. So you have your function, your let statement, your pictures. You can identify domain if they ask you for it. You can make a little sketch with your intercepts, and you can realize it has to be between here and here. On your graphing calculator, all you need to do is enter this function, x times 10 minus 2x times 6 minus 2x. Okay? And when we hit enter, we're going to go ahead and hit graph now, and you can see that it's going to graph. I limited what my domain and range were on the picture. So I went from 0 to 4 and from 0 to 40 by 10s on the y, so you can see it. And you can see this is halfway, and the peak is going to occur right here, a little bit further to the left than halfway. Your graphing calculator will figure out where that value is. So you're going to do second function, calculate. What are we trying to calculate? Maximum. So we're going to go with number 4. Now, you see the little spider on the graph? Everyone see the spider? That spider, first off, they're asking you to find the left bound. So you want to move the spider to the left side of the maximum. Make sure it's way left. Don't make it close. And then hit enter. And then it asks you for a right bound. So you move the spider to the right of the maximum. And all you're trying to do is find a region for the graphing calculator to work in. So you want the maximum between the left and the right that you choose. So hit enter. Now whoever programmed this, put in a guess thing here. So if you want to guess, boys and girls, you should enter a guess right now. I don't really care. So I don't play the guessing game with the calculator, and I just hit enter, and it's going to tell you the x value is 1.214, and the y value is 32.835. What was the question asking you? What is the maximum volume of such a box? So your answer should be the max volume, the max volume is, I can't remember what it said, 32.835. 32.835 what? Inches cubed. Okay, try to set this one up, but this one's a little bit different than the last one. Not a lot different, but a little bit different. In that the starting piece of metal is a square, and that's how this one changes. So the starting piece is a square. What would the domain be? You get it?
has to be greater than 0 and less than 5.
So greater than 0 and less than 5. So from 0 to 5 for your domain. And the interval notation is the best way to use it. So you're welcome to use set notation too. If you'd rather do x is greater than 0, less than 5, that's fine. They're going to ask you to use this in IB and in calculus. So the calculus teachers asked me, and the IB teacher asked us, can we start showing you the IB notation? So I'm going to show it to you. They'll demand it. Okay? So we have x times 10 minus 2x squared, and we want to go from 0 to 5. So if we go to our graphing calculator, and so we're going to have x times, was it 10 minus 2x squared? Okay, x times 10 minus 2x squared. So if we graph that, we're going to need to change, for me I have to change my window, and I need to go from 0, I'm going to go to 6, and I have no idea how high this needs to be. Let's see, too far for me. Okay, so I need to get my window to go up higher on the y, so let's go to maybe, and you can actually see where it bounces. So it's double root right here, and we have to be positive from here and here. And you can see really we skew way far left on this graph. So if I want to calculate, second function calculate, and again we want the maximum, and my spider is going to move, come on, anywhere to the left, enter, and then just get her over the top. I don't know that it's really a her, but anyone want to guess? Good. And then the maximum is going to be at 1 2/3, 74.074. So the 1.666, I would expect you to put 1 2/3 for your x. What value of x that maximizes v of x? That would be 1 2/3. Or if you wanted to put 5 over 3, either of those would be fine. The decimal's not going to be fine. One exact values. Now you can't get the exact, oh, you could get the exact value if you plug in, but off of your graphing calculator, I would take the 74.074. 74.074. Inches? Centimeters, thank you. Centimeters cubed. So the max volume, 74.074 centimeters cubed. Anybody have any questions on this? Okay, this is on your calendar, and if you have not printed September's calendar, you should do that soon. This is your homework assignment. You have a quiz tomorrow on the first 3 sections, so these problems won't be on the quiz. These problems won't be on the quiz. There's 8 questions on the quiz. On the test, I haven't looked at it, but as I said a moment ago, I think the test has a quadratic word problem, not a cubic, so you don't need the graphic calculator. But I'll let you know for sure by the time you get it. And then somebody asked for review stuff you could do on for the quiz. So I guess this stuff right here would kind of relate to reviewing for the quiz. I think that's going to be part of a homework assignment coming up anyway. I think tomorrow is a review day, if I'm not mistaken. Okay. You have a calendar. Look on the calendar. So yes, we're going to have a test soon. But that's why I give you these calendars, so that you can have all of those. This is a problem from your homework. I think it's number 3, where you have something with a perimeter of 20, and you're going to divide it into 4 equal pieces, and you're going to fold it into a box. with open ends. So x, 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 and x. And if it's 20, that means the semi-perimeter of one length and one width have to be 10. So 10 minus 4x would be the height of that piece of paper. So this is in your homework as well.